Hi guys, today we're going to do the penny oxidation lab. And so when pennies are first minted, they're really bright and shiny. Their copper shows through unhindered. However, over time, they turn brownish and they appear dirty. And this is because copper in pennies are subject to corrosion. Copper tends to corrode when it's exposed to oxygen. This means that a penny is going to corrode when simply exposed to oxygen in the air that we breathe every day, and it's going to form a copper oxide layer, okay? The copper reacts with oxygen molecules in a process called oxidation. And each of the oxygen atoms in an oxygen molecule combine with the copper atom, and the result is 2 molecules of copper oxide. After oxidation has taken place, the byproduct of this reaction leaves a layer of green film or a patina on the surface of the penny. The scientific term for this green layer of corrosion is copper hydroxide carbonate. However, when we put the pennies in a vinegar and salt mixture, the vinegar and the salt react together and they will dissolve that copper oxide on the penny. So this is an oxidation reaction. Oxidation occurs when an atom, molecule, or ion loses 1 or more electrons in a chemical solution. And so when oxidation occurs, the oxidation state of the chemical species increases, okay? An oxidizing agent is a substance which oxidizes something else, and a reducing agent reduces something else. In this case, our oxidizing agent is the oxygen itself because it's giving an oxygen to another substance, okay? When copper is oxidized in air, oxygen atoms in an oxygen molecule combines with the copper atom, and the result is the molecules of copper oxide forming on the penny, giving it that dirty brownish look, okay? So before we do that, we are going to actually clean our accumulated copper dioxide off of our pennies. And so the reaction that occurs while the penny is being cleaned is we have acetic acid plus water and sodium chloride plus copper oxide reacts to form acetic acid and ions in solution. So we're going to have some hydroxide, some sodium, some chloride, and some copper ions in our solution left over. The mixture of vinegar and salt dissolve the copper oxide. They're going to clean the penny. The penny is hopefully going to become shiny. And the copper oxide buildup on the penny is going to be dissolved in the mixture of salt and vinegar, again, leaving copper ions in solution. The longer you leave the pennies in the solution, hopefully the cleaner your pennies will be. Okay? And this is what happened earlier when I did this experiment to try and clean the copper oxide off my pennies. Hi guys, today we're going to be running the penny oxidation lab. So we're going to be cleaning our pennies first, and so we're taking our penny that might look like this in some serious need of love and cleaning to hopefully something that looks more akin to this, okay? So I need a couple things before I can get started. I need a non-metallic bowl. I need a plastic spoon. I need some salt. I need my handy dandy vinegar. And I need some really gross pennies like this that just really need some tender love and care. And so there's my really, really gross pennies, okay? So the first thing I'm gonna do is I'm going to take a 1/4 cup of vinegar and pour it into my bowl, like so. Then I'm going to take some salt. I'm going to take about a teaspoon of salt into my bowl. All right. And then I'm going to take my little plastic spoon and I'm going to stir my salt and vinegar, sorry, salt and vinegar solution until it hopefully goes clear. Okay, so I'm just going to keep stirring. Just keep stirring, right? Okay, until it gets clear. Put it down to make it a little easier to stir. Takes a little bit. Really trying to dissolve the salt in the vinegar. Getting closer. Okay, so now you can see still a little bit cloudy, so we're going to just keep stirring just a little bit longer, but it's getting better. Okay, so now I've got a clear vinegar salt solution. Okay. So into this clear vinegar salt solution, I'm going to put my really ugly, dirty pennies in order for it to clean them. Okay. So there we go. There's my pennies. I'm going to drop them in there. right away, I can see some kind of like buzzing that's happening, okay, as my pennies are undergoing that reaction. Okay, it's trying to dissolve the carbon dioxide that's on my penny. And I'm just gonna let them sit there for a little bit, and we'll check back in them in just a little while. And when I went ahead and checked back in with them, I was able to take my pennies out of solution. Hi, we're back. So it's been an hour and 20 minutes that our pennies have been in our sodium chloride vinegar solution. And you can see as the reaction has occurred, it's been a lot of like gas formation that's been going on. And the pennies have been started to be cleaned. And although they're not quite as bright and shiny as I'd hoped, they are a good deal cleaner than when they went in. And so what we're going to do next is we're going to take our pennies out of the sodium chloride vinegar solution, and we are going to lay them on a paper towel. And what we're hoping to see is now that our vinegar has dissolved that copper oxide that was on the surface of the pennies, and it's actually dissolved a little bit of a layer of copper itself that's still on the pennies, it should react with the oxygen in the air and along with the salt, and it should produce what's called malachite. Malachite is a bluish green compound, and fun fact for you, it's what actually gives Lady Liberty her color. So she is actually covered in a malachite compound. Okay. So there we go. I've got my new pennies, on my paper towel there. And so they're just gonna sit about an hour, and then we'll check in on them. Okay, while we're doing that, I'm gonna take some steel bolts that I got from the hardware store. And steel is gonna be, it's an alloy. And what we're going to do is we're going to insert it in our sodium chloride vinegar solution. So what should happen is we still should have some copper ions that are floating around in solution. And what should happen then is the vinegar will dissolve a layer of the steel, and it's going to allow the copper ions to bind to the surface of our bolt. And so in a sense, we're going to be copper plating our bolts. Okay, so I'm just going to take these guys and I'm just going to drop them in that solution that we had, and I'm going to let them sit, and we'll check back on our bolts and our pennies in about an hour. Okay, and so that's exactly what we did. And so this is the picture here is showing our pennies after I pulled them out of solution. They were still not super shiny, but they are a good deal cleaner than what they went in. After about an hour of drying off on my paper towel, you can see a very faint layer of oxidation that's happening on these pennies here. I almost couldn't see it at all. It's just, you have to really look. But when I did move the penny on the paper towel, you could see that malachite forming that's left over from the oxidation of the penny. So it's actually some malachite's rubbing off on my paper towel. All right, our bolts did a little bit better. You can see after soaking in the sodium chloride, or sorry, before soaking in the sodium chloride vinegar solution, our bolts were nice and shiny. They were bright. After soaking in our sodium chloride solution for an hour, you could see they were darkened up quite a bit. And what that is, that darkening is the copper ions adhering to the surface of the bolt. Okay. So our salt vinegar solution, it dissolves some of the iron on the bolt. It oxidized the surface of the bolt, leaving a negative charge on the surface. The opposite charges attract, so the positively charged copper ion was attracted to the bolt, and it formed a copper coating on the bolt. Okay, all right, thank you. I hope you enjoy my presentation today.